In this video, I'm going to go through the steps on how to find the inverses on the scrimmages that you took in class. So the first one is meant to be a little bit easier, the functions, and you can use either method for this function, either the undo method or the switch and solve method. So I'm going to start with the undo method. With the undo method, you want to start using the inverse notation, and then figure out how to work backwards to get x by itself, how to undo the function. So since we have two terms, the first thing we'll want to get rid of is the plus 5. So we start by subtracting 5 from x. The next thing we'll want to get rid of is this 1/2 right here because it's outside of the exponent. So some people were dividing by 1/2 or dividing by 0.5. It's not very standard to divide by a fraction or a decimal. So what we'd want to do instead is multiply by the reciprocal. And the reciprocal of 1/2 is 2 over 1 or just 2. So to get rid of the 1/2, we want to multiply the entire thing by 2. So we put it in parentheses to multiply the entire expression by 2. The next thing we want to get rid of is the square. The inverse operation of squaring is square rooting, so we need to square root the entire expression. And then the last thing we get rid of is the -3 by adding 3. You can choose to leave the inverse like this, or you can distribute the 2 on the inside if you'd like. So either of these would be acceptable final answers. The next thing I'm going to go through is for question A if you decided to use the switch and solve method. So with switch and solve, we change our outputs to inputs. So the f of x becomes x, and the x becomes y. And then we solve for y. So the first thing we'll want to get rid of is the plus 5 by subtracting 5 from each side. And since x and 5 aren't like terms, we have to write them separately. And then the next thing we get rid of is the 1/2. And the way we get rid of that is by multiplying by the reciprocal, which is 2. And do the same thing on both sides. Making sure to use parentheses so that you are multiplying both the x and the -5 by 2. You can leave it like that, or like in the other problem, you can distribute the 2 out if you would like. The next thing we need to do is to get rid of the square by square rooting both sides. And then get rid of the -3 by adding 3 to each side. The last thing you need to remember to do if you're using this method is to change your final answer to the inverse notation. So change the y to the inverse of f of x and write your final expression. Remember that if you didn't distribute the 2, your final answer is still correct. So the other acceptable form looks like this. The second question is a little bit more challenging because we have 2 x's in the equation and we have an x in the denominator. This tells us that we have to use the switch and solve method to start. So each g of x, each output, kind of think of it like y, gets changed to x. Remember to change both x's to y's here in the equation. So once we do the switching, the next step is to solve for y. To get rid of the fraction, you can either multiply both sides by the denominator, or you can cross multiply. So 2y times 1 gives us 2y, and then I have to multiply in this direction as well. The goal is to solve for y, and since we have 2 y's in the equation, we want to distribute. And then we need to get all terms involving a y to one side and all terms not involving a y to the other side. You can send it to either side, it doesn't really matter. In this case, since I already have a y over here and my only term not involving an x is over here, I'm going to move this xy by subtracting xy from each side. I write the terms separately since they're not like terms. And then I'm left with this as my expression. The reason that we do that is now we have y's on the left side, so we're able to factor out a y of each of those terms. So I write a y out front, parentheses, and if I factor a y out of this term, I'll be left with 2. And if I factor a y out of this term, I'll be left with negative x. And the right side will stay negative x. And now I only have one y in my equation, so to get it by itself, I just divide by this 2 minus x on each side. So that'll cancel those out, and I'll just be left with y. Last step is to use the inverse notation. And then this is my final answer. Keep in mind, if at this point you decided to put all the y's to the right side and everything else to the left side, you would end up with a slightly different expression. So if you end up with x over x minus 2, that is also an acceptable answer.